All right, so can you guys see my screen now?
Yes, sir.
Yes, sir.
Okay, so I will just explain on what are the things that you're going to do here in your laboratory number 1 and 2. So this one is one file wherein a combination of, or two in one actually. So it is lab 1 and lab 2. So I already combined the AC voltage measurement and then the AC current measurement. Okay, so the objectives of this laboratory is to learn how to measure AC voltage, measure AC voltage and current. Okay, and then to become familiar with the use of AC voltmeters. So as you can see right here, I've mentioned here voltmeters because this one is came from the module itself, from the face-to-face module. Okay, and I cannot change this one because this is what we really use in the industry. Okay, voltmeter. Okay, we cannot say using LT spice. Okay, so I highly suggest that once, let's say, ano ba? I'm not requiring you guys to buy a voltmeter, but let's say once you experience using voltmeter, please do this one uh, in more in-depth learning, okay? Because this one, you won't really be able to learn how to use voltmeter in this uh, scenario right now, okay? Because you're going to use a simulator instead of a voltmeter, okay? So I highly suggest that use this one once you have the opportunity, okay? Anytime, okay? So not right now, but soon, okay? Once you have the time or once you have the opportunity to use a voltmeter. Or if you have the money, okay? You have the means to buy a voltmeter, then please do so because this is really, really needed in your course, especially we are computer engineering. So it is a combination of hardware and software. So this will be very useful once you're using an Arduino or using a Raspberry Pi or any with the use of circuit. Okay. So discussion for this one. So an AC voltmeter is a useful instrument used to measure AC voltages and current. So it must be connected in parallel with the terminals of the circuit elements whose AC voltage we wish to measure. So take note, this is very important. So in reality, you have to measure that one in parallel, okay? Not in series, because if not, you're not be able to get the real value of that current or voltage. So the indication of AC voltmeter usually is the effective RMS or root mean squares. Or this is just basically the average of the current that you're getting on that or on that circuit. Value of an AC voltage. So besides the polarity, AC voltmeters use the same rules as DC voltmeters do. Okay, so whatever that you're doing in DC, so it is also applicable in AC. Since AC voltage reverses its polarity periodically, AC voltmeters are therefore designed without limit in polarity. So as you can see in DC, we have polarity. We have to follow that certain polarity. If you do it this way, you'll get positive, and then if you do it the other way around, you'll get negative. But in AC, so it is designed in any polarity. Okay, so you can measure it like this or like that. Okay, so you will get the same answer since in AC, you're getting positive and negative. All right, so introducing to you the low pass filter. So this is uh, one schematic or circuit that I think of. Okay, so what is this low pass filter? So it is a filter that passes signals with a frequency lower than a selected cutoff frequency and attenuate signals with frequencies higher than the cutoff frequency. So the exact frequency response of the filter depends on the filter design. So we have high pass filter, we have low pass filter, but in this case, we have a low pass filter. So from the word itself, a low pass filter will only allow low voltage. Higher than this standard or higher than this preset voltage in that low pass filter will not be accepted. So in other words, it is a circuit that can be designed to modify, reshape, or reject all unwanted high frequency. Okay, so vice versa of the high pass filter. So it will not allow low uh, frequency, okay? But instead, it will only allow up to this point or minimum up to the higher frequency. So an electrical signal and accept or pass only those signals wanted by the circuit's designer. Okay. So we have here the procedure. Using a low-pass filter, measure the voltage output of the circuit below and the current across through the circuit. Okay, so this is actually very simple. I just would like you guys to know how to set it up in LTSpice. So this laboratory number 1 and 2 is like more on the introduction on how to use the LTSpice. Okay, so we have here the circuit of the LT's low-pass filter. Sorry. Okay, and then it is created from LTSpice. So as you can see right here, we have the voltage source, a resistor of 1 kilo ohms, and then a capacitor of 1 microfarad. And then you're going to measure here the voltage output. Same with the current across the circuit. Okay, since this one is in series, so the current across through the circuit is just the same in everything. Okay, so I put here the instruction. What is it? Okay, instruction on how to do it step by step. Okay, so I will leave this one to you. Okay, so this is now your task to analyze this one and then set it up as something like this. Okay, so AC1, I've mentioned it already also how to do that one, AC1, and then the simulation command on the AC analysis, I've also put it right here. Okay, on how to do this one, AC octave from you're going to get a 100 100, what do you call that one? Wait, let me see. 100 new schematic AC analysis octave. So I put here 100 number of points per octave. And then the next one is the 1. This is the starting of the frequency. And then the last one is the 100K. So our frequency is ranging from 1 to 100 kilohertz. Okay, so if you click this one, you will get this one. Okay, so everything is in there already. Okay, so once you're done setting it up, so click run to start simulating and start measuring the V out and hold out to measure the current on V out. Okay, so let me just create another circuit. Let's say we have a voltage divider. So F2 and then type voltage and then just put it right there. And then of course in voltage divider we have 2 resistors. Okay, and they are connected like this. Of course we need the ground. Oops. So G for ground, and then a voltage output. There's a label. Voltage output. V out. I'll change it to V out. Okay, I'll put it right here. There you go. So let's say we have here 10K. So right click this one to change the value of the resistance. So 10K, and then let's say right here is 20K. And then let's say this one is 10 volts. Okay, I'm just clicking the right click to tree and then put in a certain component and then right click, and then that's the time that you can change the value of that certain component. Okay, so in this one is in DC output. Okay, so let me just show to you. Okay, so since it's in DC, so you can put here 5 seconds or 5 nanoseconds. It doesn't matter since the result will be the same because it's in direct current or direct voltage. And then once you're done with that, so click run and then put the probe here, and then we should get 10 volts. So as you can see, we have here 10 volts. And then what about if we put it on the V out? So in here, we will get roughly 6.666 or 6.667. So it's in the middle of those two. So if you want to zoom in, if you want to get the exact value, so you can always zoom in on that one. So just left click and then drag and then make a selection, something like this. And then it will show you a closer value of our simulator. So in here we have 6.66664 or maybe 6.66665. So it's between 0.64 and then 0.68. So it's 1, 2, 3, 5 decimals. So 0.6668, 0.6664. Okay. And then as you can see, this one is in direct voltage output. So if you want to change this one in AC, okay, so all you need to do is right click this one and then go to advanced. So right click the voltage source, go to advanced, and then it will show you this one, independent voltage source of V1. So this is an indicator that you're changing the or modifying the V1. Okay. So in here, for now, we're going to choose none, and then we will only use this one, small signal AC analysis. And then we will apply 1 volts instead of 10 volts. Okay. So let's see if this will show us an AC output. I forgot something. Okay. So in here in AC, it is actually giving us a constant value of 10 volts. So for us to get an AC, since this one is indirect current, we should change this one. Okay. So start external DC supply voltage at 0 volts. So instead of having an initial voltage of 10 volts, we will start at 0. So from there, we will see that there's a variation from 0 to 10 or 0 to up to what is the number of that one. Okay. So as you can see, we've changed the parameters here. Trans 5 seconds startup. Okay. Nothing's changed. V out, I think it's in the current. It is still in direct current. So in here we have upswing. I forgot to click the run. Still the same. There you go. So now we have here a value of 0 microamps, 30 or 320 microamps. So there you go. We now have a shift of value from 30 microamps to 330 microamps within 8 or within 20 microseconds. Okay. So from 0 microseconds to 20 microseconds, we have here a value or a rising value. Okay, from 0 or from 30 microamps to 330 microamps. Okay. So the same concept with your laboratory number 1 and 2. So I've already put here that change the amplitude only into 1. Okay. Other than that, do not change anything anymore. All right. So one more thing that you need to know is, of course, double clicking this one will give you the voltage output. And then the other one is giving you, let's say, holding the alt will give you the current. Okay. The current, oops, why is it IR1 minus IR2? It will give you the current of this one. And then the next one that you need to know is getting the power. Okay. So as you can see right here, as I click or as I hold the alt button, okay, it will give us a thermometer. So meaning you're measuring the power on this component, okay, on the R1. So as you can see right here, we have here from 0 milliwatts to 1.1 milliwatts. So it took him maybe also the same 20 microseconds to reach that 1.1 milliwatts. Okay. So yeah, so we have 3 ways. Double clicking will give you the voltage output, and then holding alt and then showing this icon will give you the current. And then if you want to get the power, just hover that to a certain component like resistor. Okay, so we have here the power of R1 and then power of R2. Okay, so that's how you do it. So for now, just do this one. Okay, just a simple circuit. This one is a low pass filter. Okay, so once you're done with that one, take a screenshot of your simulation graph, then paste it right here. So we have here a space, so you can paste it right here. And then some basic explanation about AC analysis, the tab AC analysis. So we have here the uh, AC analysis. So we have here the type of sweep. Okay, so it could be octave, decade, linear, and list. So this one will give you 2 points. If I'm not correct, 2 times. Yeah, this will give you 2 times for octave, and then for decade from the word itself, 10 times. And then for linear, we have an equal interval, and then for the list, this will specify frequency in list. And then for the number of points, this one, the second one, number of points, in octave, number of points per octave is estimated from 20 to 40. And then for decade, it is ranging from 30 to 100. And then for linear, it's a total number of points. So depending on the number of points that you put on that blank. Okay, and then start frequency and then stop frequency. So from the word itself, this is the starting frequency. Let's say 1 to, let's say, 10 kilohertz or 1 megahertz, and so on and so forth. Okay. All right, so that's it for now for your lab 1 and lab 2. I will upload soon for the power in AC. Okay, that would be your laboratory number 3. Okay, so for now, just do this one, lab 1 and lab 2. Okay, so do you guys have a question so far? And then one more thing, let's say you want to get the peak value of this one. Okay, let's say we have here a sine wave. Let me see if I can change this one into sine wave. So actually, we've choose the simple AC analysis. You can actually change the wave into sine wave. So let's say we have an amplitude of 1, a frequency of 10 kilohertz, and then just that one. So let's see if we'll get a different result. It's the same. Anyway, let's say we have here a sine wave. Maybe it's not applicable in this circuit. Say we have here a sine wave. If you want to get the peak value, so you can click to the label of that one, and then you can move this one, this vertical line. So as you can see right here, we have the horizontal, meaning it is the microseconds that or the elapsed time. Okay, so at exactly 29.700 microseconds, our microamps is 333.333. Okay, so this is the measured current. Okay, so as you can see, it's not changing, of course, since we have here a linear or a constant value of current. So everything is 333.33. But if it's sine wave, then you will be able to track it one by one. And then you will be able to see the peak right here. So something like that. It will change the vertical value and then the horizontal value. So take note that this is the horizontal value and then this is the vertical value. Whatever is that one. Could be a current or a voltage output. All right, what else? I think that's it only. So do you guys have a question or clarification so far on how to use the AC analysis? Question or clarification? And then you can also change the color if you want, but not necessary. I just want to share. You can right click this one and then this will show. So from the default color of green, so you can change it to red or any color that you want. Okay. And then let's say you have here two different outputs. Let's say you want to retain the IR1, so you can always delete the other one. So just right click VN001 and then delete this trace. So in that case, this will give you a single result. So just avoid confusion. Any questions so far or clarification?
Answer.
All right. So for now, that is it for now. Okay. So since I cannot think of another circuit that you can create, so I've only looked for a very simple circuit. So our goal here is for you to be able to measure an AC circuit. Okay. So a low pass filter or a high pass filter will be a very good example. Okay. So just take a screenshot on that one, and then you can play on that one, of course. So you can measure the highest voltage or the peak voltage or the minimum voltage. Okay. All right, so if you guys do not have a question anymore, I have already uploaded this one in our canvas, so you can check that one. Okay, Electro Lab. So just go to modules, and then I've also uploaded here the past Zoom meeting, and then some LT Spice guidelines, and then some hotkeys for the LT Spice. And then here's the instruction for the lab 1 and lab 2, and then here's where you can submit the file, okay, of lab 1 and lab 2. So you can use this one, okay, just paste here your answer or your result, okay, and then submit it right here. So this one is a total of 50 points, 25 points for the lab 1, and then 25 points for the laboratory number 2. So later on, maybe I will also upload for the laboratory number 3. So I'm not sure what time. If I'm not busy, maybe I will be able to finish that this afternoon. All right, so that's it. So if you guys have, or if you don't have a question anymore, so you may now leave and then have your dinner already.
Thank you, sir.
Thank you, sir.
Lunch.
Yes, sir.
Sorry, not dinner, lunch. So
Thank you,
excited.
sir.
All right, so goodbye.
Thank you, sir.
Yes,
Bye,
sir.
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 Thank you, sir.
All right, welcome.